Hey guys, in this video I'm going to show you how to configure MPLS. It stands for Multi-Protocol Label Switching. In MPLS, data packets are assigned different labels and forwarding decision is based on these labels. So this allows the creation of end-to-end circuits and enables separation of traffic. MPLS lies between layer 2 and layer 3, so it's said to be layer 2.5 protocol. As you can see in the topology, we have got 4 provider and 8 customer edge routers. On customer edge routers on both sides, I'll configure IGP such as RIP, OSPF, EIGRP, and also BGP. So let's start with router 7, which is our provider edge router. We will configure VRF on this router. VRF command here to see if we have got any VRFs configured. So we'll create our first VRF. VRF definition R7 to R9 with route distinguisher of 9 to 10. Route distinguishers are used to make the prefixes from different customers unique. So address family IPv4 with route target of 9 to 10. Route targets are used to tell the provider edge router on the other side which VRF to put it in. So we'll exit from here and create our second VRF, which is R7 to R11 with route distinguisher of 11 to 13, address family IPv4, route target 11 to 13, and we'll exit from here and create our third VRF, R7 to R12, with route distinguisher of 12 to 14, address family IPv4, route target 12 to 14, and we'll exit from here and we'll issue show VRF, and we see that we have got our 3 VRFs in here. I have issued show CDP neighbor here to see which routers are connected to which interfaces. So let's go to fast Ethernet 00 and put it in VRF R7 to R9. Here we are reassigning the IP address because once we assign an interface to a particular VRF, the IP addresses are erased. So we'll exit from here. We'll go to the next interface, which is fast Ethernet 2/0. We'll put it in VRF R7 to R11. We'll retype the IP address here. 155.1.117 and 7 with 24-bit subnet mask. We'll exit from here. We'll go to the third interface, fast Ethernet 2/1. We'll put it in VRF R7 to R12. I will reassign the IP address here. 155.1.127.7 with 24-bit subnet mask. We'll exit from here and issue show VRF, and we see that the interfaces are assigned to these particular VRFs. So let's ping IP address 155.179.9 and we see that it's successful. And let's ping the other IP address here. We see that this one is also successful. And the third IP address. And we see that our VRF is successfully configured here. So let's go to router 8, which is our another provider edge router. So we see that we have got no VRFs configured. So we'll repeat the same procedure here. We'll create our first VRF definition R8 to R10 with route distinguisher of 9 to 10, address family IPv4, with route target of 9 to 10. We'll exit from here and we'll create our second VRF. VRF definition R8 to R13 with route distinguisher of 11 to 13. Address family IPv4. With route target of 11 to 13. We'll exit from here. And we'll create our third VRF, R8 to R14. With route distinguisher of 12 to 14. Address family IPv4. Route target of 12 to 14. We'll exit from here and issue do show VRF, and we see that we have got our 3 VRFs. We'll issue show CDP neighbor to see which routers we're connected to. We'll go to the first interface, Fast Ethernet 1/1. We'll assign it to VRF R8 to R10 and reassign the IP address here. We'll exit from here and go to Fast Ethernet 2/0. We'll assign it to VRF R8 to R13 and we will reassign the IP address here. And we'll exit here and go to the third interface, Fast Ethernet 2/1, and assign it to VRF R8 to R14. And we'll reassign the IP address. And exit from here. And we'll check the VRFs again. We see that the interfaces are assigned to these particular VRFs. So let's ping the IP address 155.1.108.10 and we see that it's successful. And let's ping the other IP address 155.1.138.13. That's also successful, and also the third one 155.1.148.14, and this one's also working. So we have configured our second VRF on router 8 here, and we'll go to router 6 and configure our first VRF here, R6 to R15. Route distinguisher of 15 to 16, address family IPv4 with route target of 15 to 16. We'll exit from here. I will do show CDP neighbor, and we see that we are using Fast Ethernet 1/1 to connect to router 15, and we will assign it to VRF R6 to R15, and we will reassign the IP address here. With 24-bit subnet mask. So we will ping router 15. And we see that it's working. So VRF R6 to R15 is successfully configured. Next, we will go to router 2, and here we will configure our VRF R2 to R16 with route distinguisher of 15 to 16, address family IPv4 with route target of 15 to 16. We'll exit from here and we will issue show CDP neighbor, and we see that we are using fast Ethernet 1/1 to connect to router 16. So we will assign our interface to VRF R2 to R16, and again we will reassign the IP address here. And we are pinging router 16 here. And we see that it's successful. So next we will assign MPLS label ranges on all core routers. We will issue MPLS label range 700 to 799 for router 7. And we will use similar command on router 6 and other routers as well. Next we will configure OSPF on all core routers in area 0, and we will also enable LDP here. So here we are issuing network command, and to enable LDP we'll issue MPLS LDP autoconfig. And we will follow the same procedure on router 6. So after network command we're issuing MPLS LDP autoconfig to enable LDP. And again the same procedure for router 3. And for router 1 as well. and finally on router 8 as well. Next, I'll make sure that OSPF adjacencies are established between the core routers. So I'll ping from router 7 to router 8's loopback address. So OSPF takes some time to establish the adjacencies. So it may take a few seconds here. So let's ping the loopback address of router 8 and we see that it's working here. Here I'm issuing show MPLS LDP neighbor to make sure that LDP neighborships are established between all the core routers. So I'm issuing the same command for all core routers here. Next, I'm issuing trace route to router 8's loopback address to make sure that a labeled switch path is established from router 7 to router 8, and we see that it's working here. Next, we'll configure BGP adjacency between router 7 and router 8, and also between router 6 and router 2. So here we are issuing neighbor 151.8.8 and specifying loopback 0 as a source interface. Address family IPv4, neighbor 151.8.8 activate. And we'll go to router 8 and configure BGP and autonomous system number 100. We'll issue neighbor 151.7.7, remote autonomous system number 100, and specify update source as loopback 0. Address family IPv4, neighbor 151.7.7 activate. Okay, and it's working. Next, we'll configure BGP and autonomous system number 100. Neighbor 151.2.2 remote AS100. Neighbor 151.2.2 update source loopback 0. Address family IPv4. Neighbor 151.2.2 activate. We will also configure BGP and autonomous system number 100 on router 2. And neighbor 151.6.6 remote autonomous system number 100. Neighbor 151.6.6 update source loopback 0. Address family IPv4. Neighbor 151.6.6 activate. and we see that it's working. Next comes an important step of enabling an extra BGP capability, which is VPNv4. It's used to exchange VPNv4 prefixes or NLRI. So we'll configure it on both router 7 and router 8 using address family VPNv4 and neighbor 151.77 activate. To verify, we'll issue show BGP VPNv4 unicast all summary. We will also configure it on router 6 and router 2 using address family VPNv4 neighbor 151.22 activate. Address family VPNv4 neighbor 151.66 activate. Do show BGP VPNv4 unicast all summary. And we see that it's working. Next, we'll establish BGP neighbor adjacency between router 9 and router 10 to enable them to exchange routes through the MPLS network. So we'll go to router 9 and check if a routing protocol is configured here. And we see that there's no routing protocol configured. So we'll configure BGP autonomous system number 9 here and type the IP address of router 7 here. And we are redistributing our connected routes so that our loopback addresses are advertised by BGP. So we'll go to router 7 and inside the BGP address family IPv4 VRF R7 to R9, then type in the address of router 9, which is 155.179.9 remote autonomous system number 9, and we see that the neighborship is up. And we see that we are learning a route from router 9. So let's go to router 10 and we see that we have got no routing protocol configured here. So we'll configure BGP and autonomous system number 10 and specify the IP address of router 8 as our neighbor. So I'm checking which interface am I using to connect to router 8. So that's fast Ethernet 00. So update source is gonna be fast Ethernet 00. And we are redistributing our connected routes here. Now let's go to router 8 and address family IPv4 VRF R8 to R10 and specify router 10's IP address here. and we see that neighborship is up. And we are using fast Ethernet 1/1 to connect to router 10. And we see that we are learning the loopback address of router 9 here, and we can ping it as well. So if we trace route to router 9, we see that our traffic is going through the MPLS network here. We can see the label, so that was successful. Just to verify on router 4, which is one of the routers and core of the MPLS, we can see that it has no idea how to reach this prefix, but it knows how to forward the traffic from one PE to the other one, so which is really amazing. Next, we'll configure OSPF on router 11 and 13 so that they can exchange routes through the MPLS network. We can see that we have no routing protocol configured, so we'll configure OSPF here. Network 155.100 and area 0. On router 7, we'll configure OSPF as well. And we can see that the adjacency is up here. And we are redistributing BGP learned routes into OSPF and also OSPF routes into BGP. So we'll exit from here. Do show BGP VPNv4 unicast all summary. Next we'll go to router 13 and we see that we have got no routing protocol configured, so we'll configure OSPF here. Network 155.100, area 0. So next we'll go to router 8 and configure OSPF here as well. and we see that the adjacency is up. So we are redistributing BGP into OSPF and also OSPF into BGP. Do show IP route, and we should be able to reach router 11. So we'll ping the loopback address of router 11, and we're able to ping it. So we'll also trace route to router 11, and we see that our traffic is going through the MPLS network. So next I'll configure EIGRP between router 12 and 14. So on router 12, I'll check if I have got already a routing protocol here. So there's no routing protocol configured. So let's configure EIGRP. No auto summary. Network 155, 112, 127, 0. Network 151, 12, 12, 0. So we can see that I just configured EIGRP here. Now let's go to router 7 and configure EIGRP as well. Router EIGRP1, address family IPv4, VRF, R7 to R12, then exit, and address family IPv4, VRF, R7 to R12, autonomous system number 1, network 155.127.0. So the neighborship is up, adjacency is up here. So next I'll redistribute EIGRP into BGP and BGP into EIGRP. So router BGP 100, address family IPv4, VRF R7 to R12, redistribute EIGRP1. Next router EIGRP1, address family IPv4, VRF R7 to R12, autonomous system number 1, redistribute BGP 100, metric, bandwidth, we'll specify the bandwidth, then the delay, load MTU, we'll exit from here, then BGP VPNv4 unicast all summary, Then on router 14, I'm also going to configure EIGRP, so we can see that I've got no routing protocol configured here. So configure EIGRP, no auto summary. I'm issuing the network commands here. So we got no neighborship here. Let's go to router 8 and router EIGRP1, address family IPv4 VRF R8 to R14, autonomous system number 1, no auto summary, issuing the network commands. So the adjacency is up here. Next, I'll redistribute BGP into EIGRP, specifying the speed. And finally MTU. I'll exit from here. Show BGP VPNv4 unicast all summary. Exiting from here. Router BGP 100. Address family IPv4 VRF R8 to R14. Redistribute EIGRP1. Into show BGP VPNv4 unicast all. Let's check if we have learned the routes from router 12, and we can see the loopback address of router 12 here. So let's ping it, and we are able to reach it. Let's also trace route to loopback address of router 12, and we can see that our traffic is going through the MPLS network here. So that's done. So next I'll configure RIP on router 15 and BGP on router 16. So let's go to router 15. And we can see that I have no routing protocol configured. So I'll configure RIP here. Router RIP address family IPv4. Unicast. No auto summary. And then issuing the network command here. And then let's go to router 6 and I'll configure RIP here, address family, IPv4, unicast, VRF, R6 to R15, no auto summary, issuing the network command. and redistributing BGP 100, metric transparent, exit, then going back to BGP 100, address family IPv4 VRF R6 to R15, redistribute RIP, do show BGP VPNv4 unicast all, exiting, just making sure that I have issued no auto summary command here. And on router 2, let's go to BGP 100, address family, IPv4 VRF, R2 to R16, neighbor, 155.162.16 remote autonomous system number 16. Let's go to router 16 and configure BGP here, so we can see we have got no routing protocol configured. Router BGP 16, neighbor 155.162.2 remote autonomous system number 100. Update source, fast Ethernet 0/0. So redistributing the connected links, sending the updates. And we are not learning the route from router 15. I wonder why. So let's go back to router 15 and see if we are learning routes from router 16, and we are not. Okay, something's wrong here. So I'll try to troubleshoot this one. So let's see where lies the problem. Maybe it's because BGP hasn't sent the updates yet. So issuing the do clear IPBGP store route command, checking the RIP configuration on router 6. Seems to be okay. And still we are not learning the route from router 16. So Checking the BGP configuration here on router 16. So checking the configuration again here. And we are not learning the route. So let's go back to RIP configuration here and specify the version. Maybe it's because of the version. So I'm issuing the version 2 command here. let's go back to router 15 and see the configuration here. And we have no version specified here, so let's go to RIP configuration and issue the version 2 command. No auto summary. Show IP route, and we're learning the route from router 16. So if you don't issue the version command, you won't be able to make it work. So it's really important that you issue the version command here. So let's try to ping the loopback address of router 16, and we are able to reach it. And we are trace routing to router 16's loopback address. And we can see that we are going through the MPLS network, so the problem is solved. And we can see that we are learning router 15's loopback as well. So let's ping to router 15's loopback address, and we are able to reach it. Also, let's trace a route to router 15's loopback address, and we can see that we are going through the MPLS network. So problem is solved.